Hi friends, so today we are going to see a question called smallest difference. So what we have to do is, given two inputs, two arrays, we need to find out the absolute difference closest to 0. That is, we need to find the smallest absolute difference. So absolute difference is nothing but if you take two numbers, one from here and one from here, you subtract that one, and then you take the absolute of the result. So what we have to do is nothing but this one. You should find the you should do a minus b, and then you should take its absolute, and whichever number is closest to 0, you should return those two elements. So first starting element will be this one, and should be from this array, and one more element should be from this array. So for example, in this one, if you see 28 from here and minus 26 from here, you subtract that one, so you will get 2. So 2 is the number closest to 0, so the output over here is 28 and 26. So that's it. So to solve this one, so there are like two methods. So one is the brute force approach. So what we do is we iterate over the first array, then we iterate over the second array. So each element from the first array we check the second one, and if it is and we check whether it is the smallest or not, then we go to the next element, 1 minus 1 and 17, then again we check whether it is the smallest or not. If it is the smallest, then the first one we store that one, and then we move over here, we check whether it is the smallest or not, then we move over here, like that. So next we shift this to 3 and iterate all of this. Next we shift this to 5 and we iterate through all of this. So that will have an n square time. So that is not good. So let's do it in much lesser time complexity. So what we can do without solving this using two for loops is, first make this have two markers, point to this the first element here and the second element over here. So then what we have to do is we get 15 minus 1. So the absolute of this one is 16, right? So in this case, so we got 16. So we need to reduce this number, right? So we need to reduce this number because we need to find the number closest to 0. So to reduce this number, we have to move this pointer to over here. So why? Because I'll tell you why we have to move that pointer. So our goal is to reduce this one to 0, as close as possible to 0. So we know that okay, one more thing I forgot to say, whenever we get this array, right, so we need to first step we have to do is we need to sort the element. So to implement this lesser time complexity, this is method 2. So to implement that one, we need to first sort this one, sort both the arrays. So now they are already sorted. So what we do here is, since we have to get this number closest to 0, so we need to, so we know that among 15 and minus 1, so minus 1 is the lower than 15, it is lesser than 15. So we need to increase the number lesser than the lesser number, because we know that even if you try to increase there's no point in increasing this one, because if we do if we do -1 and 17, if we do -1 and 17, this and find the absolute difference, this number will increase. So but we don't want that one, we want it to decrease. So that's why we always move the pointer containing the lower number, right? So let's do this now. So initially it is pointing to this one, so we get pen. So we get -1 and -15. So this is equal to -16, right? So since this is we have to take, so after doing this subtraction we just need to take the absolute difference. So after taking absolute difference we get 16. So the 16 has to be reduced to 0, so there is no point in moving this one to this one, because this will anyway increase it to, it will become, the difference will become greater than 16. So we move this one, we move the left pointer. Okay, so now we get 3 and -15. So 15, 14, 13, 12. So we get 12 as this one. So again, so tell me which pointer to move. If we try to move, so our goal is to reduce this one to 0. So if we move this one again, it will become 17. So it will be 3 minus 17, which is 17, 16, 15, 14. So that number will increase. So there is no point in increasing this one. So we want this one to reduce. So which is the smaller number over here? 3. So we move this pointer to 5. So next what we get is 5 minus 15. So which is equal to minus 10. Sorry, not minus. Take the absolute difference. So taking the absolute difference, we'll get 10. So as you can see, now the number is reducing to getting closer and closer to 0. So next what we do is we take this 5, since again 5 and 15, 5 is the lesser number, we take this one and move it to 10. Okay, so next what will happen? So we do 10 minus 15. So again this will be 5. So next again, so 10 is lesser than 15. So now over here we move this pointer only. So now we get 20 minus 15. Minus, which is equal to 5. So in this case now 20 is greater than 15. So if we try to move again this left pointer, we'll get 28 minus 15. So 28 minus 15 is 28 minus 15 is almost 13. So it's increasing, so there's no point in moving this one to this one. So the key point is we need to move the pointer of the lesser number. So the point, so this is the lesser number, so we move this one to here. So now we do 20 minus 17. So this is 3. now after doing so, now which is the lesser number so next which is the lesser number between 20 and 17? So this is 17. So 17, we move this pointer to 26. So now we do 20 minus 26. Minus 26 is give me 4. So now what we do 20 and 26, so which is the lesser number? So 28. So we move this one to 28. So next we do 28 minus 26. So it is equal to 4 2. Okay, so next what we do is, so this is 28 and this is 26. So we need to move the lesser number, so you get the point, right? So next we do 28 minus 134, whatever we get. So in the end we just need to iterate till the end of the array. So and then whichever so what we can do is, whenever we find the difference, first we'll find the initial difference 15 and minus 1. So if then we store, so if the next difference is lesser than this difference, we store this one as the new result, and we add these two numbers to the new array. Again we do the next subtraction. So if this result is lesser than this result, we do the comparison. If that's the case, we store this one as the new array and the new difference as this one. Again we do this one. If this new difference is lesser than the previous difference, so we store this in a new array, and we store the new difference in a new value. So like this we go on, and then after iterating out of this loop, the lowest we can return the integer, you can return the array containing these both as the lowest values. So here 2 is the lowest values. So that's it. So let's look at the algorithm. So step 1 is sort both arrays. Step 2 is keep pointers. Step 3 initialize smallest difference, so I'll just call it ST, is equal to mat.abs of array1 LP minus 80 RP sorry. So and then Step 4, what so we'll create iterate till end of both arrays reached. So step 5, so inside this one, inside while iterating, we do a absolute difference. We will just call it absolute difference. Absolute difference is equal to math dot abs array1 of LP minus array2 of RP. So if AD is lesser than SD, so the new smallest difference will become, so AD will become the new smallest difference. So AD will become the new smallest difference, and create array with AOLP and ATRP. Next. So now the important part, if the left pointer is lesser than the right pointer, LP is lesser than AO of RP. This is array 2 of RP. Then we do LP plus plus else we do RP plus plus. So after the array we return the array which we created over here. So that's it, guys. This is the steps. So let's get into the coding part. So the time complexity for this one is equal to O of n is equal to n log, I'll just call it O of time. So it should be n log n plus m log m, where n is the number of elements in the first array and m is the number of elements in the second array. So both of these arrays can have different number of elements. So n log n because we need to sort both the arrays, so best sorting algorithm will take n log n time, and then we are iterating through all the elements, so that one we can take it as just n plus m, so it should be n log n plus m log m plus n plus m, but n plus m is negligible compared to this one, so we'll ignore n plus m and we'll just do for this. We'll just stick with this. So space complexity is O of 1, so space is O of 1 since we are just returning a two array element, so 2 element array. So that's it. So first let's check out the brute force approach. So for that one you just need to compare each element with each of the other elements. So let's iterate over through the first one. I lesser than array 1 dot length I plus plus so now we are iterating over the second array. So before that one, let's smallest, so int smallest, I'll just call it SD, smallest difference is equal to math dot abs of array 1 abs of array 1 of 0 minus array 2 of 0. So this is the smallest difference. So let's just assume this one. So here we will do int difference int difference is equal to array 1 minus, so let's copy this, so this should be array of I and array of j, that close this. So if AD is lesser than ST, this one becomes the new smallest one. So smallest difference is equal to AD, and we create a array. So I'll just create one array over here, int result is equal to new int result, which is having 2 elements, length is 2. So result, okay, So result is equal to sorry, okay, result is equal to uh, that new array, create a new array int. So this is array 1 of I and comma array 2 of j. So that's it. Okay, now we have created this one. So with each of the element it will check the result, and then for loop ends over here. So here I just have to return result. Let's run this. $62. What is this? Bracket expected int. Oh, okay, this is the format for declaring the array. Cannot find symbol array1. Okay, here it is A and B. I used array1 and change it here only. Array1 and array2. Now run it. It's failing. So if AD is lesser than SD, so SD is equal to AD and result is equal to new result array of 1 and array of array of 2 of j. We are storing that result. So what's the mistake we are doing here? So first we are storing array of 1 and array of 2, array of 2 of 0, so minus 1 and minus 15. Minus 1 minus 15, so 16. So result okay, why this is not working? So first we take absolute difference. Okay, array1 dot length, array2 dot length. Okay, fine. So here we just need to find the we have to do mat dot absolute over here. mat.abs. Okay, so that's it, guys. So this is for the first one. So this is n square time complexity and O of 1 time. So let's do the second approach, which is this one. So arrays dot sort first step. So this is the first step. So arrays dot sort array 1, shit. Next keep the 2 pointers. So int lp is point to 0 and int lp comma rp is equal to 0. Sorry friends, something is wrong with this keyboard, laptop keyboard. Shit. Equal to 0. Next, initialize int sd is equal to mat.abs of AO array 1 of lp So now while we take a while loop. Shit, sorry guys. Okay guys, 1 minute, I will get my keyboard external. Okay. So while array of 1 while lp is less than or equal to array 1 dot and then are equal to array of 2 dot 2 dot length. So inside that one int add is equal to math.abs of array 1 of lp minus array 2 of rp if AD is lesser than SD. SD is equal to AD. So I'll just declare that one array same like this one. So here I'll just take this three if of 1 array of 1 this pointer is the rp else rp plus plus. So next is the end of the loop. Yes, we return result. Not fine. Array 1 okay, this should be pointer, this one should be the right pointer. Okay. Is equal to 0. Both of them are initialized. Okay. Line number 87. Okay, should this length should not be lesser than or equal to, it should be lesser than. Okay, so now it passed. Okay, that's all guys. Sorry guys, yesterday I couldn't sleep. Okay, thank you for watching.